Well, hello, calculus students and general seekers of truth. Let us continue our study of simple derivative rules here by doing actually the opposite of a derivative, namely an antiderivative. So before I define what an antiderivative is, let's just solve this problem. Let f prime of x equal x cubed plus 5. Find f of x. Well, this problem is totally solvable using the methods that we know. We know that if we take the derivative of something and you get x to the third, using what we know about the power rule, then the antiderivative, or the original function, must have had x to the fourth as its power. And this 5 here, the antiderivative must have been 5x, right? Because if you take the derivative of f, you will get x to the third plus 5. Except for one little change. If you were to take the derivative of f, you wouldn't exactly get x to the third, you would get 4x to the third. So in order to adjust for that difference, we need to multiply the front here and introduce a coefficient of 1/4. So let's see why that works. All right. So I'm basically introducing a guess and check method here. I've guessed already. So let's check. What is f prime? Well, applying the rule that we know, we have 4 times 1/4 x to the third plus 5. This 4 and 1/4 cancels, so we end up with just 1/3. We just end up with 1x cubed plus 5. Okay, so yes, this works. This is definitely our answer. Okay. Now you can kind of see the process here. Rather than just guessing and check, this coefficient is always going to be the reciprocal of this number. This number here is a 4, so we need to multiply by the reciprocal of this power here, so that when we take the derivative, the coefficient in the front cancels out and we get what we're looking for. So in this case, we can say that the definition of antiderivative is pretty simple. We can just say this the following: f prime is the derivative of f, and the antiderivative just means the thing you took the derivative of. So f is the antiderivative of f prime. Okay. Now, that about captures what you need to know for antiderivative, but there's one little wrinkle in this problem. There is more than one solution to this problem. For example, let me propose a different solution. Let me propose a solution where f of x is equal to 1/4 x to the fourth plus 5x plus 8. Okay, and let's see why this works. If you were to take f prime, you would still get x to the third plus 5, and then the derivative of 8 here, of this constant, is just 0. So this is also a good solution. And you can kind of see here, well, let me kind of beat this idea down to the ground here. Here's another possible choice: 1/4 x to the fourth plus 5x plus or minus 19. That also works as a solution, right? So you can see that with antiderivatives, they are not unique. All right, so let's make this big note here that antiderivatives are not unique. There are infinitely many answers because we have lots and lots of constants that we can attach to the end here. So what we'll do here is we'll write an answer in terms of the general solution. So f of x plus, f of x equals 1/4 x to the fourth plus 5x plus, and I'll use a capital C here, and this is any constant. Okay, so any real number will work here. So we call this the general solution, and this is probably a good way to end this lesson here, that this is probably the best answer that we can give here because it captures all of the possible solutions. Okay? So hopefully you get a sense of finding an antiderivative, the process that's involved. In the next example, in the next video, we'll talk about how to find a specific antiderivative.